Hey there, everybody. Welcome back. We are doing 8.4. This is on multiplying radicals. And recall we had our product rule. Nth root of a times b is nth root of a times nth root of b. And this is a two-way formula. Goes both ways. Here we're taking it apart. Or we could start with them separated and put them together. So what this says is if we have the same index, we can multiply the insides. Multiply radicands. We also multiply coefficients. Okay. Let's do some examples. We've got the cube root of 4 times the cube root of 16. This equals the cube root of 4 times 16. And 16 is 4 times 4. So this is the cube root of 4 cubed. And that's just 4. So sometimes by putting them together, we can get rid of the radical altogether. If we have cube root, no, we don't need cube root. Let's just do square root. Square root of 3x y to the 4th times 6x, square root is 6x to the 7th y cubed. There's two ways to go. Path A. We put them together by multiplying the insides. We've got 3 times 6 times x to the 8th times y to the 7th. Six is 3 times 2. So this becomes 3 squared times 2 times x to the 8th times, this has got an index of 2. Since there's no index listed, I'm going to do even exponents. I'm going to write this as y to the 6th power times y. So these will come out. 3 to the 2 over 2, x to the 8 over 2, y to the 6 over 2. And I'm left with the square root of 2y. X to the 4th, y cubed, square root of 2y. That's path A. Path B. Separate what you can first. Here, a y squared comes out. This is y squared times the square root of 3x. Times here, I can take out an x, 3 x's, and a y. And I'm left with 6xy. Now, when I multiply these together, the inside's a little easier to work with. We've got x cubed, y cubed, square root of 3 times 6 times x squared y. Again, we split that up into 3 squared times 2 times x squared times y. And those come out. I get another 3 and another x outside. And I'm left with the square root of 2y. And we clean that up, we get that. I personally think, I don't know, option A is a little bit easier. Here, I feel like I'm simplifying once and then I'm simplifying again. Here, I'm just putting them together, then simplifying. So I feel like I'm not simplifying as many times. Okay. Give you more to try. Let's do the fourth root. Of 36a squared b to the fourth power times the fourth root of 12a to the fifth power b cubed. All right, I'll assume you paused the video and went with this. I'm going to say right now, you are a fool if you did 36 times 12. What is that? Where's my calculator here? Let's do a calculator right here. $36 times 12. 2, and then tried to factor 432. Work smarter, not harder. It's okay to be a fool once if you didn't think about it. Learn from it. Look how much easier this is if we don't do that. We're going to put them together, of course. But I'm going to write these as things I recognize. 36 is 4 times 9 real quick. 12 is 4 times 3. And I'm going to combine my a squareds. A to the 7th power. And I'm going to combine my b's, b to the 7th power. I guess I didn't need that long of a radical. And now I'm going to split this up a little bit more. 4 is 2 squared. So I've got another 2 squared. I've got 2 to the 4th power. 9 is 3 squared. I got another 3. This is 3 cubed. A to the 7th, b to the 7th. Now I'm looking for powers of 4. So I can break up the 7s into 4 plus 3. So I've got fourth root. I'll put all the things with a 4 on it first. A to the 4th power, b to the 4th power. And I'm left behind with a 3 cubed, a cubed, and a b cubed. These first 4, or not 4, first 3 come out. They all have an exponent of 4. 4 over 4, the index is 1. So they all come out to the first power. And we're left with the fourth root. I'm not going to leave it as 3 cubed. I'm going to write it as 27a cubed b cubed. That's simplified. Multiplied and simplified. All right. More with multiplication. We can also distribute. So let's say we have the square root of x and we're multiplying it by square root of x minus 2. This becomes square root of x squared minus square root of 2x. Nope. minus 2 square root of x. Look at me making a mistake. Here we multiply, since they're both radicals, we multiply the insides. Here, there's no radicals, so they just multiply together. And this first one simplifies to x. So we have x minus 2 square root of x. All right, we can do 4 minus square root of 3x, and we can square that bad boy. You really, really should write it out, because if you don't write it out, you're going to screw it up. Half the students, at least half the students, screw it up if they try to jump straight to the answer with this. It is not 4 squared and that squared. Here we've got 4 times 4 is 16. And then we're going to do 4 times that is minus 4 square root of 3x. So I did first and then I did outside. Now I'm going to do inside, which is minus another 4 square root of 3x. And then I'm going to do last. 2 negatives make a positive. And I have 9x squared on the inside. Or better yet, 3x squared like that. You could write 9x squared, but I think this way you see the radical and the index go away, or the radical and power go away. These two combine into 8 square root of 3x. And I've got plus 3x. That's a valid answer, but most people will put the radical last. I've got 3x plus 16 minus 8 times the square root of 3x. All right. 2 more examples. You guys try this one. Square root of 15 minus 2 times square root of 6 plus 3. All right, we distribute. We've got square root of 15 times 6. That's our first. Then we do outside is 3 times the square root of 15. Then we do inside, which is 2 times square root of 6 minus. And then we do last. 2 times 3 is 6. Those last 3 we can't do anything about. Let's see about this one. This is 3 times 5 times 3 times 2. It looks like we got a 3 squared in there. 3 squared times 10. I'll do that real quick. We got 3 square root of 10, and then we got the rest. Plus 3 square root of 15, minus 2 square root of 6, minus 6. And that's it. We don't have any like radicals. That's done deal. Messy, right? Let's give this one a try. We're going to do square root of 3u minus 2 square root of v. And I'm going to multiply it by square root of 3u plus 2 square root of v. All right, when we multiply, we do the first. I get square root of 3u squared When I do outside, I get plus 2. And then I multiply the radicands. I have square root of 3uv. Let's do an outside. And when I do inside, I've got minus 2 and another square root of 3uv. And when I do last, I got minus 2 times minus 2 is minus 4. And I got square root of b squared. So here, the radical and the power cancel. I'm just left with 3u. These two cancel. One's positive, one's negative. And here, the exponent and radical cancel again, and I'm left with minus 4b. So this entirely simplifies down to 3u minus 2v. No radicals. This may look familiar from when we did factoring. What we have going on here is this looks like a minus b times a plus b. And if you remember back from factoring, that was a squared minus b squared. Three u minus 2 square root of v. 3u plus 2 square root of v. I get square root of 3u squared minus 2 square root of v squared. This is 3u minus 4v. These are called conjugates. Conjugates. If we have a root b plus c root d, and we multiply it by a root b minus c root d, we get a radical free product. Or outcome. Product is the results of multiplication. It actually ends up equaling a squared b minus c squared d. But I don't know that that's helpful. I think treating it like we did the factoring, I think this is the more helpful form to picture. It's easier to remember, and it does the same thing. But it's important to know that when you have radicals in them, the radicals are not in the outcome. They should cancel out. And that'll be it for 8.4. Peace. Stop this video.